Hey class, it's Professor Nick Sensky at UNC Charlotte, and this is the Lab 2 video, Lab 2 script, you might call it, that we're going to use as a supplement for your lab report. And what I'm going to do is I'm going to show you a couple of techniques that build on the things that we looked at in the skills video earlier in the week, and I'm going to ask you some questions in the lab handout, and you'll be able to answer them if you follow along and you solve a couple of puzzles that I give you along the way. Okay, so to get started, I'm going to go ahead and create a center box. You saw a whole lot of these in the video, right? We saw how we use math to manipulate them and create relationships between multiple center boxes. And one of the problems we had with the center box, though, was that it is centered on the plane. So if you look at it in the front view, it's not sitting on the ground. It's sort of halfway embedded in the ground. Okay. And what I want to do is I want to start this lesson by showing you how to fix that. Okay. Now we looked at the box component, and we looked at how there's a size in the X, Y, and Z. And I talked about how there's this plane, and that actually determines where the box is. Okay, but I didn't talk much about that. So if you go into the vectors, there are various kinds of planes. And planes are, if you remember from math class, it's like basically they're defined by any 3 points. And they're sort of a flat surface that things can have different relationships to. But the planes that we typically understand and use are like the XY plane, which is actually what we might consider the ground in a drawing. There's just a very flat surface. It's imaginary. It's a mathematical construct. But for all intents and purposes, the XY plane is the ground in a 3D model. Okay. There's the ZX plane, which is this kind of plane that would be facing you in the front. And there's the ZY plane, which is the kind of plane that's perpendicular to that. That's vertical. So if this is like the front elevation or south elevation, this might be what you consider the side or the east and west elevation, so the flat planes, okay? And if you go into plane, you can see that we actually have kind of stock XY planes, XZ planes, and all other manners of planes. And we can use those to change the position of the box from the get-go, okay? But what I want to do is that right now I want to keep the box kind of on this plane. I want to keep it flat. So I'm going to use an XY plane. So drop an XY plane, and you plug it in, and nothing happens. Okay. Why? If you look at the origin of the plane, it's still 0, 0, 0. And so by dropping an XY plane and putting a box on it, you haven't changed anything. But look at this. What does it want for the origin? It wants a point. 0, 0, 0. Okay? And again, I'm not going to be able to cover everything in Grasshopper, but as you explore, remember I told you how to understand, what the components want. What does this component want? Okay? It wants a point object. So if we go in, look under point, there's actually a component that's called point XYZ. Create a point from XYZ coordinates. That seems to make a lot of sense. So if I put that point piece in here, you look at it, it's actually that green. It has X, Y, and Z, and they're all numbers. And that makes a whole lot of sense, right? If you put a number in there, you get, it changes the point. So let's just go ahead and put a number slider in there with a value of 0 to 10, and just put it into the X. Okay, and notice that, if I zoom out here, by changing the X coordinate, I change the point, and if I change the point, I change the plane, and if I change the plane, I change the location of the box. Now, this looks like the move command, right? But it's not the move command because it's not based on geometry that we're moving. We're changing where the box even begins from. Okay, check this out. If I unplug this, plug it into the Z, I can move the box. I can change the location of the box up and down. Okay, And so, you know, that's actually the solution to our problem. Okay? If we look at this in the front view, we can see that if we move this to here, pretty close, I can't get it exactly, but if we move this to 1, the box seems to be sitting on the ground. And so what is that? Like, we can kind of experimentally figure that out, right? If the box has dimensions of 1 by 1 by 1, if you move the box up by 1, then it's now on the ground, the way you'd expect it to be. Okay? So how would we kind of solve that puzzle that we had here of getting it to sit on the ground? Right now it's at 1. Any thoughts? Give it a try, and then come back. Okay. Okay. If you've come back, if you notice that if you plug in the component to Z, like nothing happens, but as you change the size of Z, you'll notice that we maintain a position on the ground. Okay. Why does that work? Okay, that's a question that I'm going to ask you in the handout. Okay, what's happening there? Okay, okay, let's go ahead and starting from like this idea, I'm going to go ahead and disconnect these. Let's look at another scenario that happens. Actually, I'm going to go ahead and keep these together. Sorry. I like this. I like when my box sits on the ground. Okay, I'm gonna go top view. All right, let's go ahead and turn these off, and let's make a copy of all these. Okay, so now I've got 2 boxes. Can we put 2 boxes so that they are side by side? Okay, that's the next thing. Okay, it's a similar idea to what we used to reposition this. How would you reposition a box when its x dimension changes? So if I move this, how would you make this box move to here? Okay, using using all the components that we already have, right? How would you reposition that box so that it's always, so that box number 2 is always on the edge of box number 1, right? When you resize this, it shrinks. I mean, it moves, and when you resize this other one, well, in the X, it also moves. Okay, so instead of these things being inside of each other, which is no good, can't build that. How do we get them to go side by side? Okay, that's a question. So you can kind of experiment with this, right? And I encourage you to. So one thing that we can do is to say, well, if this one moves, we're going to change the X of where this box is, right? So let's plug this in to X. Oh, that's pretty good, right? Like if I move this, it's starting to move the box, but something's not quite right with it though. Like it's not, when I move this, see, look at that. It's actually, what's happening there? It's in the middle of this. Remember what happened when we did this before, and like this was sitting in the middle when we did the boxes in the like X dimension? Okay, let's go ahead and experiment with that. I'll show you again. Remember that without this, the box was centered in the middle, but then when we reconnected this into Z, so if you take the size of the box and you displace the plane by that same amount, it basically takes it to the edge instead of the middle. Okay, So let's go back to where we were. Okay, we got something stuck in the middle. How do we get that to move to the outside? Okay, give it a shot and come back if you have an idea. Okay. Okay, let's see what you tried. What I think would work is if you can play with this dimension, and you can play with this dimension. So this seems to be fine. What we need to do though is we need to find some way of, if this is in the middle, we need to move it this same amount, as well as moving it the amount of this box in the X. Okay, so we have to move it this much and this much. Okay, did you figure that out? If not, think about this though. You have to move it this much and this much. Okay, think about it. Come back. Okay, did you look at the addition component? Because that's the idea. We're going to take this amount and add it to this amount, and then plug that in for X. And that's actually going to give us such that this one appears to come out of it, and it starts with this other piece. So these two are actually like related to each other. Notice that the heights can change. Oops, wrong frame set up there. But they appear to be joined at the side. And that's all because we use math to manipulate the relationship between the two. Okay? It might have been a little difficult, but if you think about it, if you look at it experimentally, the problem was that we needed to add this amount to this other amount in order to produce the right amount of displacement for this. Okay? Okay. So you've got that. So I'm gonna ask you a challenge then. Okay. So starting from, I'm gonna disconnect this. So if we've got a box, how do we make it so that in a similar way to what I just showed you, this box is always on top of the other box? Okay? And then, once you figure that out, how do you make it so that the box that's on top is always 1/3 of the height of the base box? Okay? This is really similar to what we talked about, what I showed you in lab last week. Okay? So, a couple of little puzzles. Okay? Try it out. Try some things. Don't just plug things in and see what it does. Like, really think about it. Sketch it if you need to. Work with your partner together. I've given you all the tools and I've given you all the clues. All you need to do is think about what you did, what I just showed you, to move this in the X dimension, and that's how you figure out how to get a box on top of a box in the Z dimension. Okay? You'll need to add another component, but I think you'll figure it out. Okay, and that's really important. Like that basically demonstrates the kind of logic of the simple house that I showed you. Okay, didn't show you how to make the pitched roof yet, but you can have a proportion that's based on an existing unit, and they're adjacent to each other. Okay, which is really important. They don't float in space or something. Okay, and now they're coming out of the ground, which is great. So now we have our center boxes that actually appear to sit on the ground. Okay, so go through with this, and then when you're done, I'll see you in part 2. For part 2 of the lab, we're going to be exploring columns, basically. And if you remember from history class, columns are based on a series of proportions, which makes them ideal for exploring parametric relationships. They're not really things that we make use of much today, but proportions are certainly things that architects have to know about. So I think it's a good thing to start with. Rather than try to design our own proportions, let's just start with some that are already pre-designed and that are kind of known to be attractive or aesthetically pleasing. So I have an image that I'm going to give you on Moodle that's of a series of classical column orders. And what we're going to do is essentially construct a tool, a script in Rhinoceros, in Grasshopper that lets us modify a column so that it can basically adjust to any one of these orders. Just for example, I have something that I can change the pedestal, can change the width of the column, and the other pieces will adjust proportionately. The base and the shaft and the capital. Okay. So all these different things, I can adjust the cross sections and the scales of those, so they're all essentially parametric. Okay. So that's really where we're headed. But in order to get there, we have to kind of start at the basics. So what I'm going to do is go ahead and open up Grasshopper. And in the last video, we looked at circle as a shape. That's one of the shapes I asked you guys to play with last time. So let's go ahead and start with that. Go to curve, primitive, circle. And if you notice, circle has a radius, it's a number, and it has a base plane. Okay, so it has like a location where the circle starts. Okay, and what I'm gonna do is basically start by adding a number slider for the radius, and we'll just give it 10 and 1 is the limit. Let's call this base radius. Okay, and so we can play with the radius of the circle. Easy peasy. Next thing I'm going to do is something that I showed you guys in the skills video, is use a move component. And we're going to move something up and down. And when we do that, right, we need a vector. That's what T wants. So looking at the bottom here, if we want to move something up and down, which direction do we want the vector to be in? That's right, it's a z vector. Okay, so let's go ahead and drop a unit z, and we have the multiplier, and it wants geometry, so we put in the circle, and you can see that we get another state of the circle. So we have the base circle, literally the base actually of the column, and then the next one is going to be this section. So what we're trying to do is we're drawing this piece here, and the next cross section we're going to draw is going to be this one. So it's kind of an abstraction. It's not, there's a lot going on here, but we're just going to take a curve here and a curve here and create that base. And the base, right, the top of it is, if we look at this, it's actually smaller than this is. Okay, so we'll get to that. And it's also above it. So we're going to take this, and we're going to call this one base height. And this one we can really turn down quite a bit. I don't want the base to be that big, so it's just really, well, we'll get to that later, but just edit this a bit here. You know, just edit these later. The trick is just to get the components in that you want. So I've got radius and a height, and notice that since this move of the circle is based on the circle, when I update the radius, it propagates to the other component. So we've established a dependency between them. That's how they're related. It's pretty slick. Okay. Next thing I'm going to do is, remember, if we put these two as a cross section, they're actually going to be flat, and we want them to taper. And so what we need to do is actually make this cross section slightly smaller than that cross section. So what we're going to do to make it smaller is make a scale component and add it to this. So if I add this to the scale component, something's wrong here. Look at this. Remember what happened when we did this the last time and what the problem was? The center of scaling is wrong. Okay, we're looking at the center of scaling at 0, 0, 0. We want the center of scaling for this component. And last time I showed you a component called volume, and that works on three-dimensional forms, but a curve is really two-dimensional. And so what we want is the area component. Okay, so drop an area in. Area takes geometry and it outputs a center. So you take, and now we have the center point, and we can plug that in for scale, and now we have scale. Okay, last piece of this is the scaling factor. And since we really don't want it to be larger than the other curve, because that would look really weird, the default setting of 0 to 1, so 0 being nothing, 1 being 100%, is pretty good for a scale factor. So let's call this base, or let's call this a shaft start. So this is where the shaft begins, right at the top of the base. So we'll give it the width of that. And it's really something that's pretty close. Let's call it double click 0.75. So it's, whoa, I lost my component there. There we go. Call this 0.75. So it's, there we go. Okay. So we have the circle that we moved up, and then we scaled it. And really, since we really don't need this outside curve, I'm just going to go ahead and preview off. So I'm essentially going to hide it. It looks pretty good. Okay. Next cross section is going to be the capital. So it's going to be a tall piece. So what I'm going to do with it is make another copy of it by moving it again. I'm just going to copy all three of these, the slider and the vector and the move component, and plug this in. Let's turn this back on here. So now you can see this. Let's call this shaft height. And then let's make this really pretty big, right? Because that's the height of the shaft. So just call it 30. Okay. Oh, that doesn't seem very well proportioned, does it? 125. Probably too high, but whatever. Again, you can always edit these later. It's always good just to get a solution in place and then modify it rather than to get hung up too much on the details. You gotta just keep the problem in your head and don't allow these things to distract you, such as adjusting components. Okay, so we got the move, and then I'm going to do something pretty similar because the shaft actually tapers slightly from where it was. So let's go ahead again and let's copy these area and scale. And then let's just put the new geometry in. So now we have this, the area point, and we have the component goes into scale. Copying and pasting is really good, right? Because you already have the pattern established. You don't have to drop the components in. The trick is just not to get confused by the wires. You can always disconnect them and then reconnect them. I just like to snap them back in place. And then this other piece here is actually a problem. Because it's connected, we need a different slider connected here for the scale. What this is going to be, let's call this shaft end. And it's some proportion, and it's actually probably more like 0.9. I'm just kind of fudging here. It's a little bit smaller. And once again, we're going to hide that outer curve. So there's 3 cross sections. Then we need one more. And it's actually very similar. We're going to grab both of these because what we're going to do, right, is this last piece is moved up and it's slightly bigger. Okay. So we're going to copy paste this whole ensemble here. And we're going to go, it's going to get moved. And we need components for both of these actually. let's go ahead and copy. Let's call this. We need one for the capital height and one for, let's say, capital start. Capital. So the capital height, actually, you can't do that. Let's do capital height is going to be this first one, and, oh wait, capital start. No, actually, it's capital height and capital scale. Sorry. Again, maybe we don't get hung up with names, but got a problem there. Yeah, the capital height's way too tall. Let's bump this down to something like 10 again. That's the problem. Okay. Whew. Scale is way off. Okay, so we got the capital height and the capital scale, and we have a problem because we want this top thing to be bigger than this. So what has to happen to scale? Scale has to get bigger than 1. Let's just make it 1.5 as big as it will go. Now it's bigger. Okay, let's go ahead and hide this one. And now we have our four cross sections here. And this is your generic kind of column thing. Now let's take a step back and look at what we've got here. Let's go ahead and move these in. Got a radius for the base. And look at that. When you scale that, these are all dependent upon each other all the way through. When that radius is scaled, everything is based on that proportion. That's so powerful, okay? You can always adjust things, right? But like we can adjust the scale of this one at the top. We can always adjust. In fact, you know what? There's probably a constraint that we want to put on this. Think about this. Does it ever want to be smaller than the top? Doesn't. So what should we do? That's right, you want to change this to 100%. So it's never going to get smaller than the other piece. It shouldn't ever get smaller. It's always going to be bigger. Okay? Likewise, with this one, it's never going to get bigger than 1. It's always going to get smaller than 1. Okay? Notice how this all propagates. It's pretty powerful. Okay? So we got the base radius, height of the base, which again is pushing everything up and down. Start of the shaft, which is a scale. Height of the shaft, we just looked at. End of the shaft, which is the kind of tapering of the column. Height of the capital. And the scale of it, which is constrained. So a lot of powerful relationships. And they're all pretty logical, right? We make a circle, we moved it up, and then we scale it. And we moved that up and we scaled it, and we moved and we scaled. So it's really just a series of these operations in order to get these cross sections. Okay? Then what we do with this, in order to make this into geometry, is apply a command called Loft. And a loft is like taking a silk stocking or something and essentially wrapping it over a wire frame, right? It just creates geometry from cross sections. I'm going to kind of float it over here because here's what we're going to have to do. We have our geometry, right, where it turns green. We need to plug all of those in to the curves in Loft, and we need to do it in order. You can experiment with what happens if you don't do it in order, but I'm not going to take the time right now. So we'll take the curve, plug it in for C, and now shift click, okay, hold shift, click G, and drag this in to C. Notice what's happening already. We get some geometry. Shift click for this G, plug it in. Some weirdness happening there, we'll fix it. And then lastly, take this last one, plug it into C for Loft. Okay, some stuff's going on here with this Loft. We'll fix it pretty quickly. We're going to right click on O, go to the options for Loft, and under the settings for the kind of loft, we have normal loft, we're going to make this a straight loft. And click commit. And there you go. So you've got a piece of geometry that, and if we go into all of our different viewports, take a look at this here. Oh, I didn't burn it. That's why. Anyway, didn't bake it. But if I zoom in to different viewports, I can kind of see what happens with this thing. So now it's all skinned basically, and if I adjust it, you really get a better sense of what we got here, what's going on with this. Okay. And if you know what the proportions are or what the dimensions are for something, you can plug them in and you would get that column, right? You could also play with these until you find a pleasing set of dimensions for what you're trying to do. Maybe decide you really like a really thin tapered column. Okay, so this is a great tool again for exploring or for outputting things that you already basically want, and this makes it very, very quick. Okay, and it's constrained by different kinds of information in logical ways. So it's a great parametric tool. So I'm showing you all this basically because your assignment is to use what you've got from this lab to construct this tool, add a base to this, and then use it to output a column that works according to these orders. Okay? And you'll get more instructions on that in the handout. But everything you need is here in what I've just described.